Good morning. We are about to embark upon change that has the likes of which has never occurred before. So what I'm going to talk about certainly is AI and agentic AI and smart cities. But I'm first going to broaden that to a very general discussion about where we're going. Because where we're going, we've never been before by far. We're going to be making changes, and I'm sure you hear this in the news and this and that, kind of equivalent to the printing press or the agricultural revolution or the industrial revolution, and far bigger than the internet. Now, I've been here, as was mentioned, for 40 years in Silicon Valley, originally from Brooklyn, New York, and I've had 5 software companies. And the changes I've seen have been pretty massive. For example, one of those companies, Forte Software, we enabled the internet to basically work for mission critical apps. We enabled, as an example, the first home banking system. And at the time, people didn't believe the internet could do that. In fact, getting funding for Forte was a bit of a challenge. There was one very large VC who we met with who said, this internet thing is going to be like a flash in the pan. That was one of the partners. Another partner said, it'll be like CB radio. Another one said, my grandmother would never use it, and so on. And they turned down funding us. The logic I'm talking about is when you have a discontinuity, a shift as big as this, people don't recognize. Well, all of us are hearing it so much in the news, and people are saying things like I'm saying, it's going to be big and it's going to affect everything. How about an order of magnitude more than that? And that's what I'm going to talk about. I'm going to use a lot of examples, stuff that we've built that are occurring right now. Smart cities and cities in general, space is one of the first users of these advances, but they're going to be everywhere. So let's begin. First of all, is it clear which way we're going? I had a situation living here like this where I went over the Golden Gate Bridge and I went into a fog and I couldn't see what the hell was in front of me. Well, can we right now? Not so clear. But these major technological shifts that are occurring are going to have opportunities like we've never seen before and challenges even bigger than we think. So everyone talks about the challenges around, security, that's one, or trustworthiness of the technology, that's two. There's another challenge too. We're about to change society. We're about to change the way systems operate. And with all the complexities in our social structure and physical structure and all the feedback loops, there will be discontinuities that we can't even prepare for. And that means we need to be flexible and we need to experiment. So let's talk about how this AI system is going to reinvent our world. The first bullet is really probably the most important. That is, real-time intelligence is going to be part of everything we do. We are about to automate the world, guys, in ways that we have no idea what the impact's going to be. Now, if you think for a second, let me give an analogy. Home coffee maker. Everyone has one, right? They used to be pretty damn stupid 30, 40 years ago. Now they have a bunch of sensors in there to sense what's going on, make sure it works properly, etc. That's for just a coffee machine. Same for refrigerator, etc. How about if we do that for the whole world with systems that are so much more complex than that? Do we think we can design this? Let's not be too cocky. We're going to try, and we're going to make mistakes, and we're going to do it over and over and over again. And what that translates to is we need to experiment, and we need to change things very quickly as required. So, next thing, it's humans are going to change what we do. Agricultural revolution did it. Industrial revolution did it. AI is going to do it more so. So day-to-day things seem to be the same, but I'm telling you, under the covers, and we're seeing it because we're building, Vantiq is building some of the most sophisticated applications, which are basically around the area of smart city to address current needs. We're seeing the kinds of changes and the kinds of challenges that are being faced. And then on top of that, the third bullet, guess what? It's happening faster and faster. It'll slow down, I'm sure. No, it's not going to slow down. It's going to accelerate because we have world intelligence due to open source and other technologies contributing everywhere. First time ever. One of the benefits of the internet and what that's going to translate into technology moving quicker than ever. DeepSeek from China kind of surprised us. Well, maybe the specific use of it did, but the fact that it occurred shouldn't surprise us at all. Now, what's going to happen next month and the month after that? Put your seatbelts on. Anyway, managing complexity, though, the next bullet, is the biggest challenge. These are very complex systems with complex feedback loops. And we're not so good at modeling. How do we do at modeling climate change? I'd say not so good. Predictions are often way off. Can you really model the weather? Can you really model the ocean? Well, you can't model mankind and how things operate in the world. So therefore, the complexity that's going to occur has to be dealt with as it occurs. Meaning that there's a new dynamic we have to pay attention to, and that is real agility. Agility in everything. Yeah, agility in creating systems. We've spoken about that as a technologist. I'm familiar with it. But agility of making society change quickly too, because businesses are going to change, governments are going to change quicker than ever before. And how do we adjust? Another thing, software. I've been in software since I was like 10 years old. Well, actually a little bit hardware then. I transitioned to software, so my whole life. And what we're going to see now is that software is going to be developed by pretty much anyone, because that's what generative AI will enable. It's already starting to do that. In fact, in our system, Vantiq, generative AI is used to create a lot of the software. And we're in a long-term direction where that's going to happen more and more. Well, how about almost anyone creating the software systems? And that brings with it a lot of challenges too, like trustworthiness and security. But it's going to happen. I wouldn't bet on being a software programmer today, but I would bet on being an analyst or an architect, because how these systems are created and the thought being put into it is absolutely critical. And these systems we're creating will all be interconnected. It's not going to be, we have a supply chain system, we have a disaster management system. We're all going to work together. Now, how the hell is that going to happen? We are terrible as an industry of getting systems integrated. But we're going to have to, and that's going to require new technology solutions. And it's also going to require very quick change as needed. So to do this, the last bullet, one of the most important one, new platforms. Of course, I could talk because we have one, but we're not going to be the only one. New platforms will be created to enable this to happen, to enable change to be addressed as quickly as it occurs. There's no choice. And the one thing we can say, and this is certainly true in Silicon Valley, but it's true about the world, we as a species are technology-wise very adaptable. We react to changes very quickly. So innovations will occur at an incredible speed. So what kind of problems can we solve? What kind of problems is this technology going to be used for to address? So I'll focus a lot, of course, because of this convention, on smart cities. And in fact, smart cities is probably the first area where we're seeing the change. What are called agents. And by the way, if you're not familiar with agents, I'm sure everybody here is familiar with LLMs. You've all used ChatGPT or equivalent for sure. The agents are just LLMs with some business logic for orchestrating activities. That's it. That's what an agent is. So what kind of agents can be created to address real-time problems? Well, in the environment. How about for disaster management, like floods? When a flood occurs, how do you get the first responders to the right place at the right time with the right data? Where do you get your feedback from? Sensors, maybe a sensor that says, hey, this flooding under the bridge is getting pretty heavy, or flooding by somebody's feet is getting, a few inches deep. And satellite images and social media and other inputs. There are loads of inputs that could be combined to address environmental disasters. And since environmental disasters are occurring more and more frequently, we need to be able to address it to save lives. What about security? How do you address security when the world is going, let's admit it, a little bit bonkers in this area? All of these mass shootings that are occurring and all these new cities, these smart cities that are being built that need to assure that people can walk around pretty safely. And I think we all know that in decades ago, it was pretty safe to let your kids ride around on bicycles pretty much anywhere, not just a neighborhood, go to another neighborhood. That's kind of a scary concept for most parents today. So how do we do this without being too invasive? These are some of the challenges that we'll face. Transportation. Well, there's a transportation problem this morning. Not everybody is here because of the challenges of the airport, the freeways, etc. Now, can technology solve this? Absolutely can solve it. What if we could control every traffic light, every on-ramp, every off-ramp? And with autonomous vehicles, maybe we could do that even better because they're connected to everything, or will be. You can guide them. That's in the smart city area. The next set of use cases here is we're going to be moving into organizations, enterprises. So healthcare, it's a big market we're in, building all kinds of apps that can monitor people in real time. See from your sensors that you're wearing, most of us are wearing sensors now, and additional sensors, and saving lives. Like we're doing an application right now in Saudi Arabia, or I should say we're bidding on it, that's for the Hajj, the migration to Mecca, where thousands of people died from overheating due to the heat in the desert. Well, it turns out that there are indications of that problem for an individual before it gets real severe. Why can't you monitor that? Simple monitoring. And then get a first responder to the person, or guide the person to a safer area, or get somebody standing next to the person to help them and say, hey, you're starting to really overheat. I mean, these are the kinds of systems that are being thought through right now and are going to be built. That's healthcare. HR. HR is pretty damn limited in what it does today. So not to put down any of the current products, but what do? They have a database, they know your history, your vacation schedules, your salary schedules, etc. How do we do in terms of using human resources? I would argue we're terrible at it. Because if you look at your whole pool of resources, and we're working with a very large company in Japan right now with hundreds of thousands of humans working for them in 900 companies, and they're going to figure out for each individual, what's your best career path? What matches what you want to do and are capable of doing and what the company needs? And then offer it to you with the associated courses. Their idea is to basically change the way human resources are allocated, well beyond any technology today. And they believe that they get far more productivity because this person might be better off in this training area doing this or that, rather than following the normal promotional route. This is going to happen. This is going to change the way organizations use people. And then defense. We all know the scariness of defense. Drones, I don't need to say more. It's happening, and it's happening quickly, and we better respond quickly. Here's a video I'm going to show of an application that was built using our product in Japan. It's a 1-minute video of saving lives and what to do when disasters occur.
Natural disasters are happening more frequently and getting worse. Yet vital information and help often comes too late. In these moments, every second counts. That's why DResilio was created. DResilio is a solution that brings together critical data and gives governments, emergency teams, and infrastructure providers a clear picture in real time of what's happening. At the core is Vantiq, the real-time intelligent platform that makes it all possible. Vantiq ingests and analyzes real-time data from diverse sources such as weather forecasts, flood monitors, road conditions, drone and satellite feeds, mobile alerts, and even social media activity. By integrating these inputs with existing systems in advanced AI, Vantiq creates a live operational system that enables cities to respond faster, safer, and smarter in times of disaster. And when every second matters, that can help save lives. With NTT Data's DResilio, built with Vantiq, cities are safer, smarter, and ready for what's to come next.
This system is up and running right now. Now, for various reasons, cultural, Japan is the first country to do this. It's running in Tokyo and 4 cities around Tokyo, and soon will be running throughout Japan, funded initially by the government. They have lots of disasters in Japan, so earthquakes, floods, other types of issues. And they are addressing it. They're figuring out how to address it with all the kind of inputs I mentioned earlier, everything from social media to satellite images to sensors. They have to integrate all the first responders, whether it be the police or firemen or any kind of health worker that should be there, and get everything to work together. And talk about a complex system, more of an integration problem than anything else. But they're just starting. Now they're using generative AI, and I'll show in a few minutes how generative AI is going to help. The intent of this slide is to show which ways software is changing and rapidly. So we have software that we all kind of grew up with as being very deterministic as a programmer, which I was for years. You programmed it, you knew exactly what it to do, and if you were lucky, you would do exactly what you told it to do. What you told it to do, not what it needs to do. Major discontinuity, because what it needs to do is so much more than what you will think of in advance. Now, what's happened, that next bullet to the right is generative AI has come along and humans can ask a question. Okay, good. Humans can say, hey, there's a problem here. What do I do? Blah, blah, blah. ChatGPT or another one can help you. What if it's real time? Can you count on humans to either know the way to prompt it or to be involved, be in the loop? No, you can't, because these problems occur immediately. You need to build real-time systems, and real-time systems absolutely require the automatic generation of prompts to one or more LLMs to give recommendations and etc. This is a whole new technology, very complex technology. Now, I'm using examples from Vantiq because we actually have the most advanced examples in many of these areas, but we're not going to be the only ones. We know that. It's nice to have the first mover advantage. This is going to happen everywhere by the hyperscalers and so on. They're going to have to, we are going to have to, as a species, as a society, automate Gen AI because it's not deterministic. It could think, it could figure things out that you haven't thought of in advance. And when you program stuff, you've got to think of everyone in advance. So this type of change is going to occur, and it's occurring now. However, Mayfield Capital forecast is 2 years away. It's not 2 years away. So what do these real-time systems need to do? Ingest data from the various sources I mentioned, analyze that data, orchestrate the results, and then learn and update itself. This is the kind of platform that is absolutely needed for these complex real-time systems. And then when you look at the fact that change is occurring so quickly, sensors are becoming so much more intelligent. Just look at all the wearables and the new types that are coming out that do everything from EKGs to heat measurement to even blood pressure. We're able to monitor so much more now. And is that going to stop? It's not going to stop. It's going to accelerate like crazy. We're at the beginning of the curve of innovation for sensors. Same thing for generative AI. We're still at the beginning of the curve, with visual language models becoming the next trend. But what about, you look at a baby, what about all the inputs that humans have? We can hear an explosion. We can see a glass is about to fall off of a table. Well, generative AI systems are going to be moving in that direction as well. And we need to be able to include these technologies immediately as they occur. because you really want to see what's happening in the environment. You even want sensory, like feel. If an explosion occurs, you can actually feel the impact of it. These types of technologies are coming to the market now and need to be included and will be included very quickly. So let's look at some. I'm going to quickly go through a few case studies. So we already saw this one with DResilio. So I don't need to emphasize this one anymore, but I do want to make one point, which is the next phase of it. So what's the next phase of it going to be? Like Amber Alerts here in the US, why not tell somebody when they're in a situation that's in trouble? So why not notify an individual you are standing in a place where water is rapidly rising and you need to move out of there in the next 5 minutes? And so here, hi Sam, severe floods occurred. Do you want to evacuate? Do you want us to give you guidance? And yeah, the system will automatically give Sam guidance. Here's the route you take. If you're ambulant, you can walk fast enough. And he also has, is my mother in trouble? The system knows the address of his mother. His mother's okay. As he evacuates, or the group that he's in, all of a sudden the bridge collapses or becomes unavailable. Well, a smart system is going to know that. And guess what it's going to do? It's going to reroute him and all the people he's with immediately and update the database that keeps track of what's going on so that nobody else is guided over that bridge. This is being built now. This is the kind of advances that we're seeing. And we have the advantage, the perspective, since DResilio was built with Vantiq, so we can see and talk to NTT Data in this case about what they're doing next. And it is really exciting and innovative. And you could think of the use cases where humans can be warned. This is just one example. Public safety in the Middle East, 10,000 cameras. We're doing CAFTA, which is the most advanced smart city in the world right now. NEOM is going to come after that. So we monitor through those 10,000 cameras, look for problem people perhaps who are breaking in, possibly terrorists, and then tagging them and tracking them throughout the facility. But computer vision is not the only thing that's needed to do that. What if they have an explosive vest under their shirt? How are you going to detect that? We have 10,000 cameras, that's useless for detecting that. But radar can detect that. So how about having drones that can fly to a particular case that has radar that can be turned on at the right time and check suspected people to see if in fact they're wearing explosive vests? This is a type of technology that will be the next phase in this development. And it's possible today. In Texas, we're building a system in Texas A&M that is going to basically monitor and improve the way traffic operates. Could be used in San Francisco here for sure. But they're going to control every traffic light, every on-ramp, and also for emergency vehicles, how you get them through quickly. And the goal is to improve traffic performance and safety and security throughout Texas. And it'll fit very well with autonomous vehicles who have V2X, vehicles connected to anything. They can get the advice and you can guide them. So this is Texas first. It ain't going to be Texas last. Once these use cases are proven, they're going to spread like wildfire. No pun intended. Although wildfire is clearly another area that we could and should be monitoring. Critical infrastructure monitoring, another U.S. city, Opelika. We have this up and running. So what Vantiq does, I'm going to use as an example, because all these new platforms that are coming to market are going to have to do the same thing. First of all, it's event-driven. You're dealing in real time. You have to deal with not just one agent, but many agents working together. And that's a challenge. So let's say, for example, unfortunately, somebody you know is in the hospital and they have some type of cancer. So there's an oncologist involved, say a neurologist involved, there's your primary care physician, and each of them can be represented by this concept we call agents. They can have their own large language models, their own inputs, et cetera, and make decisions. Well, how you can control that? Is it a top-down orchestration, asking each one what they think? Don't they need to communicate to each other? Agents need to talk among agents. This is a major challenge because the architectures today do not define this. There is some work being done with A2A, Agent communications. But really, it's a very complex problem. It's a event type problem where they can all work together. We're going to see this type of evolution as well. Removing hallucinations, another challenge. We have a patent to reduce hallucinations. There are other techniques for sure, but you've got to make sure these systems are trustworthy. And there are things happening. Of course, scalable, reliable, secure, and rapidly built. Low code now, no code eventually. And these systems need to run everywhere. They need to run on your phone, they need to run in a hospital, etc. This set of requirements is very comprehensive and very complex. So what we're going to see is a whole new set of technologies coming to market to address that, to address these problems. Now, if we look at this disaster response system, the one I alluded to earlier, it has the inputs in it. So it has computer vision, video, it has augmented reality to guide the first responders to the right place in a changing environment as they move through the environment, showing the changes in which way they go. You have to inform security, inform others, but there are additional things you could add on, as shown in number 2 here. Number 3, analysis of the video streams. So you see that there's a problem, maybe a recognizable terrorist, but what happened? So video large language models can do that. Who went where and where are they going? So this is an added technology after the initial system is built. Another added technology is what about making recommendations to the first responders? So there are terrorists at the front entrance of the smart city. Don't go through that entrance. There's a sniper up on the roof. Go through the back entrance. And then monitor them as they're doing that. And then update the system, as shown here all the way in the lower right, to learn in real time what's happening, to make those changes, such as sniper up on the roof. Okay, this is admittedly a complex slide. The point I'm trying to make is you need to be able to build a system quickly and then evolve it just as quickly as new technologies become available. And they're going to become available faster and faster. So this complexity problem is very serious, very real. But as I said, technology itself will come to the forefront to enable these solutions to be built. So I covered from a very high level of what AI is capable of and how it's going to change our world, and brought it down to a much more detailed level using examples, many of which, actually all of which we've built because we tend to be able to do it. We lead in this area. But again, others will come to the front, and other technology companies will also produce products similar to us. We know that. We just have to continue to move ahead. That's the world of technology. The markets, trillions. Initially, it's a lot through the governments or the municipalities, governments that will fund disaster management. How do we deal with problems in the world? Healthcare. How do we deal with humans having issues or enabling them to live longer? And then how do we do it quickly? We got to be ready to experiment. So systems are needed that allow for a certain amount of experimentation, immediate experimentation. This LLM is going to be replaced. We're going to add this other LLM, or we're going to add acoustic sensors, or we're going to add touch sensors. It's going to be like if you look at a child, a 2-year-old, walks around and it feels everything from its 5 senses. And maybe there's a 6th sense, an energy sense that it could also pick up. We're going to automate all this stuff. We're in for a new world of computing like never before. This is far bigger than the internet, guys. Far bigger. We're about to automate our world. We better do it cautiously, and we better do it quickly. New platforms, as I mentioned, are required to do this. The older technology, just running in the cloud, it ain't going to work. It ain't going to do it. We need new ways of addressing these problems. And the area of smart cities, which this conference is about, they're being built right now. I gave you these use cases, and we're just at the beginning. So exciting times, very exciting times, but challenging times. And all of us in the technology industry have to figure out how to address these challenges. And anybody in government or any organization has to figure out, how do we use these technologies? How do we deploy them? And also get ready for the changes, the massive changes that are going to occur everywhere. That's it. I thank you.